Good morning. We're going to review today for the Math 95 final, which is tomorrow. So here we go. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All righty, so I've got some questions by request. This first one is from the Chapter 8 test, and this is number 1. So let's go to WebAssign and take a look at it. It's part 2. It says find the domain of each function. So this is part B. We have the function s of x equals 2 divided by the quantity 4x plus 5. And we are to find the domain. Okay, so let's take a look here at the whiteboard. We can't divide by 0. So if we take the denominator, which is 4x plus 5, and we set it equal to 0, and then we solve it, we find the numbers that can't be included in the domain because they make the denominator 0. So to solve this equation, we'll subtract 5 from each side. We get 4x equals -5. Divide by 4x equals -5/4. So the domain would be, let's see here, we'll say domain, all real numbers except x can't equal -5/4. So looking at our choices, we would choose this one here, the set of all real numbers except -5/4. All right, let's take a look at problem number 4 on this same test. It says, in a proposal to some prospective clients, a housing contractor listed the following costs. Fees, permits, miscellaneous, $17,000, construction per square foot, $60. Write a linear function that the clients could use to determine the cost of building a home having F square feet. So it's $60 per square foot, so 60 times F plus $17,000. Now, part B, it says, find the cost to build a home having 1,750 square feet. So we've got the function C of F equals 60F plus 17,000. We want to find C of 1,750. So going back to the whiteboard again, C of 1,750 equals 60 times 1,750 plus 17,000. Putting that into the calculator, we have 60 times 1,750 plus 17,000, and we get 122,000, and that would be dollars. Okay, next we're going to go to some questions from a Chapter 9 test. Chapter 9, let's see here. And we're going to take a look at problem number 23. Let's see here. All right. So this is Chapter 9 test number 23. Let's take a look at it here in WebAssign. It says solve the equation, write all proposed solutions. If a solution is extraneous, so indicate. All right, so we've got the square root of the quantity 6x plus 8 equals 2. And back to the whiteboard. So when we're solving an equation with one radical, we want to isolate the single radical. So we're going to subtract 8 from both sides, which means the square root of 6x equals -6. Well, a square root can't be negative, so I can already see that any solutions we get aren't going to work, but they want us to find proposed solutions. So going on, I'm going to square both sides of the equation. 6x equals -6 times -6 is positive 36. Dividing both sides by 6, we get x equals 6. Now, let's take that and plug that back in to the original equation and see what happens. We get the square root of 36 plus 8 is 2. The square root of 36 is 6. 6 plus 8 is 2. 14 equals 2. Not true. So the proposed solution would be x equals 6. Since it doesn't work, it would be called extraneous. Those are solutions that we get, but that don't work. Okay, that takes us to chapter 11. And a couple of test questions there. Let's see, number 5 and 15. So let's take a look at number 5. So this is chapter 11, test number 5. And looking at WebAssign. Assume that there are no deposits or withdrawals. An initial deposit of $11,000 earns 6% interest compounded monthly. How much will be in the account after 11 years? Round your answer to the nearest cent. Okay, first of all, we need to figure which formula to use. It says compounded monthly. So we're going to use the formula A equals P times the quantity 1 plus R over K raised to the KT power. The initial deposit, P, is $11,000. The interest rate, R, is 6%, or as a decimal, 0.06. Compounded monthly, so K is 12. How much will be in the account after 11 years? The time is 11 years, and A, the final amount, is what we're trying to determine. And we're going to round to the nearest cent, which is typical in answers involving money. So back to the whiteboard, our equation becomes A equals $11,000 times the quantity 1 plus 0.06 over 12 raised to the 12 times 11 power. Now, I can simplify things ahead of time, or I can just put this whole thing into my calculator. I'm going to just do it all at once. So I've got 11,000. Let's see here, 11,000 parentheses 1 plus 0.06 divided by 12. Then I'm going to close up those parentheses. I'm going to use my little caret power key, and then parentheses 12 times 11, close parentheses. I get 21247.74458. Rounding to the nearest cent, which would be right there, the 4 would round down. So I get $21,247.74. Now let's take a look at problem number 15 from that same test. Let's see, is that right? Looks like they've got 15 correct, but we'll go ahead and look at it anyway. Okay. So back to the WebAssign page. So this is chapter 11, test number 15. A wooden statue found in Egypt has a carbon-14 content that is 3/4 of that found in living wood. If the half-life of carbon-14 is 5,700 years, how old is the statue? Round your answer to the nearest 100 years. Okay, so we're going to use the half-life formula, which is A equals A naught times 2 to the negative T over H power. We know that the half-life is 5,700 years. Let's see here. How old is the statue? So time is the unknown. So we've got to deal with the beginning amount and the ending amount. We don't know the beginning amount, so A naught is just going to remain as A naught. The ending amount, it says let's see, a statue is found that is 3/4 of that found in living wood. So the ending amount is 3/4 of the beginning amount, which would be what? 0.75 of the beginning amount. So A equals 0.75 A naught, or A sub 0. All right. Now back to the whiteboard. So our half-life, 5,700 years. Time, we're trying to find. The beginning amount, we don't know, so we'll just leave it as A naught. The ending amount is 75% or 0.75 A naught. So we get the following. 0.75 A naught equals A naught times 2 to the negative T over 5,700 years power. We're going to divide both sides by A naught. So 0.75 equals 2 to the negative T over 5,700 power. I'm trying to solve for T, which isn't part of the exponent. So I'm going to take this exponential equation and change it into a logarithmic equation. So we get log base 2 of 0.75 equals negative T over 5,700. Now, to solve for T, I'm going to multiply by negative 5,700 on both sides of the equation. On the right side, the 5,700s reduce out, and negative times negative is positive. So I get T equals negative 5,700. I'm going to use the change of base formula, which would be the log of 0.75 divided by the log of 2. I could also use the natural log of 0.75 over the natural log of 2. So now I've got negative 5,700 log of 0.75, close that up, divided by the log of 2, close that up, and I get 2365.713746. But it said round your answer to the nearest 100 years, which would be right there. The 6 would round up. So time would equal 2400 years. Okay, those are all the questions that anybody asked. And so I'm just here alone. I'm going to go ahead and stop this recording.